Well, I was in World War II. I wasn't in combat. My brother, who was in combat, went in after I did. I was 18 years old, left high school, grew up in Florida, Daytona Beach, Florida, joined the Navy in October 27th, 1942. And my brother joined later, but he convinced me that I ought to study engineering. Now, he did go to school at University of Florida for a while, and then he was in both of us were in the Navy. And I remember we met. He was going to radio school. He was a radioman. He knew he was going to pick up his ship. It was an attack transport in Brooklyn, New York. Now, we both met in Providence, Rhode Island. And we came up with this concept that says, how are we going to stay in touch with each other? We knew they would censor our mail. Couldn't say where you're going or where you've been and all this. Mm-hmm. So he came up with the idea, when I write you a letter, I'll write Alex H. McCool. He knew he was going to the Pacific. They were going through the canal. They were going to Hawaii first, train the Marines. They would get into the landing ships and everything. So he would write me a letter to Alex H. McCool, and eventually, and I followed him all through the Pacific. I ended up in Newfoundland. I was in naval aviation, but I never was in combat. He ended up in combat, but he stayed after me. He had enough points, got out before I did, and said, go study engineering. And I'd worked in mechanical systems, crash boats and things like that, air sea rescue. And so he convinced me I'll go to school. And so he got out before I did, and I didn't know what I was going to do. And really didn't have any ideas where I wanted to go or what. Now at that time they had what they call a GI Bill that allowed us to go to college, and they paid for it. So he convinced me to go to a small school in Louisiana. At that time it was called Southwestern Institute. Today it's the University of Louisiana at Lafayette, raising Cajuns. So anyway, graduated there, and then I went to graduate school at LSU, got my master's, started working for the Army in Vicksburg, Mississippi, Corps of Engineers. Now, hydraulic design, I studied mechanical engineering, but it turns out I was working in civil engineering. My roommate in college, a good friend that I grew up with, had come to Huntsville in 1953. Jake Lennon, he passed away, he's deceased. He was in 53. Well, he called me when I was in Vicksburg. He said, won't you come up here? They're working on rockets. Well, I didn't know a rocket was anything, so I came up in 53 and early 54 is when I joined the team. They offered me 3 or 4 jobs to come work in mechanical engineering, so mechanical systems, not civil engineering, hydraulic design, dams, locks, rivers, flood control, and all that stuff. But it was a lot more interesting to me. So started working with the Germans, early team, in 54. In the meantime, while I was in Vicksburg, Mississippi, working for the Corps of Engineers, I met my wife. She was studying to be a nurse, and turns out when I was working at the experiment station, well, there was an alley there, and a residence for the nursing students, and they'd come down to this alley, and that's where I met my wife, my future wife. We got married in 53, because we just, this past July, 66 years we've been married, got 2 kids, and then they got kids, so we're great grandparents to this day. But we moved here in 54, started working on the Redstone Missile. Well, I worked in propulsion, and I wasn't sure. They sent me around different places to be interviewed by the German team, and they were all, interested in getting people. And when I go to the next guy, he tried to outdo the previous guy, tell me the interesting things they're working on. When I talked to Mr. Schultz, William Schultz, he knew, when I was being interviewed by him, he knew I'd gone to launching and handling and talked to Dr. Huter. Huter worked launching and handling and everything. Well, he sets me down by his desk and he takes out this drawing and lays it on his desk. And he says, and I could see tanks and trucks and pipelines and all that. And here's his Redstone Missile sitting on a pedestal. So he makes it clear right off the bat. He used a little psychology on me. He said, we work on this part up here of the rocket, and here's these trucks and tankers and lines, pipelines. He knew I'd been talking to launching and handling. So I was very much interested. He got my attention when he said that. He used a little psychology. I want to work on a rocket.
Yeah.
So I started working for him and with the team, 1954. It was Redstone, and we had only flown 1953. It's a very new rocket. So eventually, that's where I started in propulsion. The German team had been hiding out in 1945 in the Bavarian mountains. That's von Braun, his select team, and I did speak with a lot of them after they came here. And I'll get to that in a moment, but in 1945, the Army was very much interested in getting the technology, rocket technology, missiles, etc. Well, they, of course, did. Von Braun's team had designed and built the V2, the V1, V2 being supersonic, and that's what we got back there in this facility. That's right. Supersonic's the first supersonic rocket ever built. That means you don't hear it, you hear it when it explodes. So they're very much interested. The Army was, sent the team to Fort Bliss, Texas, okay, which is still there in El Paso, Texas, 1945. Whole gang of them came over. There was 118 of them to start with, and all that's in the history books now. You can get that. And so they came in 1945, 1950. Korean War goes on. All right. Now in the meantime, I'm going to college. Okay, 1950. They had to leave Fort Bliss, hospital facilities where von Braun and them were living. The Army was concerned about wounded, and they had hospital facilities there, and they didn't know how many. So they said, you guys got to get out of Dodge, find another place. Well, they came to Huntsville. Redstone Arsenal was here, World War II. Made bombs, mortar shells, nasty gas. And so Redstone Arsenal had closed after World War II, which ended in 1945. And so here's Redstone Arsenal. They came here. They liked it. It reminded them of the old country. Tennessee River, lakes, or hills, we call them mountains. So they liked it, so they moved here in 1950. Got heavily involved in the community, and I started work with them in 54. And I saw how they had done so much to help the community. Von Braun helped set up University of Alabama, Huntsville Research Institute. A lot of the things you see in the research park today is because of the von Braun team inspiring all that. Worked in rockets, worked on the Redstone, and that was the first thing we started working on. Now, the Army wanted another ballistic missile like the V2, but they wanted more advanced. So it had to have like a nautical range of roughly 200 nautical miles, carry a nuclear warhead. Now, V2 didn't have a nuclear warhead. And we did fire the engine, we fired the testing, had a contractor, North American Aviation, Rocketdyne, which designed the engine. And we worked very close with them. And that's what I worked on. Now the engine is very small compared, well, it's bigger. The V2 rocket, and I talk about thrust, is like 46,000 pounds, okay? Redstone engine was like 78,000 pounds. Well, it's a bigger engine, but it uses different kind of propellants. It's the same as an outgrowth of the V2 rocket, and that's where I was going to use the analogy of the car. Mm-hmm. The car have to have gasoline or diesel fuel. You take air from the atmosphere, and you mix it with that. You have a carburetor, you have fuel injector, you have to have a gas tank. Same thing in a rocket, okay? You got to have pumps to pump the thing. have to have some engine. We use spark plugs, and we use different kinds of igniters in rockets. And we use spark plugs in some of the stages of the Saturn. So it's very similar to a car. So when I tell people it's, nuts and bolts, valves, line, mechanical components and everything, pumps and everything, that's what a rocket is, what makes it go. What you want is the heat of combustion. That's what you need for your car to drive from the combustion chamber, okay, through a transmission through your rear end that makes your car go, right? Heat of combustion. No different. Now, the Germans pioneered the use of liquid oxygen for the oxidizer. You need an oxidizer to burn with a fuel. And they used 75% alcohol. Okay, and then they eventually went, and I'll talk about some of the other propellants that we use. But you have to have both propellants, and that's what we have, and that's what we have in a rocket. You have to have an oxidizer and a fuel, very similar to your car. They treated us real well, and it's all engineering, mathematics, calculations, and so forth, designing systems, and they would help us. And von Braun sometimes would play one group against the other group in the designs and everything. And so, but it was fun, really fun, encouraging stuff. You never worried about the time clock. In the early days, we rode in carpools. We didn't have a lot of 2 and 3 cars like we do today. And so you didn't stay late. You had to get out, get a ride home. We brought our lunch and everything. So, but it was a lot of fun stuff, new stuff that we're working on. It was basically engineering, using all the engineering laws and everything. And there was always somebody had a talent that could help you with your problem. I don't care if it was like restoring old cars. We had guys doing stuff like that, making furniture. The guys just talented. Had gals working with us too. He'd come around, down to earth guy, very, very interesting guy, good engineer, a lot of charisma. And we'd go to contractors and they said, well, Wernher, they call him Wernher, you don't call it Werner, Wernher. He said, you think we ought to design it this way, that way? And he'd give them ideas. They'd know how to propose on the next engine we were going to have, which is like the J2, that I'll talk about in a little while. And they'd pump him, getting ideas. And he'd come around. We had these big drawing boards. The guys would be working on the drawing, on the design, and he'd look at it and he'd talk to the guys and make comments. And he'd make notes on the drawing, and then the guys wasn't paying attention. They'd erase his drawing. So they'd listen to him and he'd show up. Eventually, von Braun was very much interested in going into space. And in the early days, in fact, when he was in Germany, in Peenemünde, that's when he got in trouble talking about sending rockets to Europe, from Europe to the North America, and sending the mail system, and he ended up being in prison. Now you can read about that history. I won't get into that, von Braun's history, how he got in jail. But Redstone was an interesting thing because he came up with this idea of putting up a satellite. And now that's history, and you can read about that for Explorer. And that was the first one we started working on. We all worked for the Department of Defense, worked for the Army, okay? Von Braun had to answer to a general, which he got a little later on. But the Secretary of Defense was and I forgot his, Roger Smith. He was the Secretary of Defense. He said the Navy is going to put up our satellite. Now we could have put up, if we'd had the 4th stage on there, and I could show you all back down there, we did fly the 3 stages. If we'd had the 4th stage on, we could have beat them. They flew in October, if you will, 1957, ahead of us. In the meantime, they said the Navy's going to do it. Kaput, 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 with our modified Viking rocket. And so then they gave us they said, okay, Army, go ahead. And ours had been in the warehouse. He told us to put ours in the warehouse, which we did. And so that's what we did in January for a satellite. I was here. I didn't go down for that. And I was down there for Alan Shepard, which was in 1961, later on. But von Braun was very much interested in putting somebody in space. He had a fellow named Kuttner, Dr. Kuttner, Jack Kuttner, who had flown the ME-262. Now that's the first jet fighter plane. He came over with von Braun and them, and he volunteered to fly on something modified on a Redstone, like Alan Shepard flew. Now, in the meantime, NASA gets formed in 1958. But concurrent with that, they picked 7 fighter pilots, all men, little short guys, hot dogs, every one of them hot dogs. 3 Navy, 3 Air Force, 1 Marine. Now, next thing you know, General Motors says, well, hey, this would be a good publicity thing. Let's let these guys have, oh boy, can't think of the high-speed Chevrolet, what is it?
Oh.
Corvettes.
Corvette,
Let them have Corvette. Now, John Glenn didn't get one. So now it's party time. These guys are all at the Cape, chasing gals, racing, having fun and everything. By the way, they got the cars through a dealership in Melbourne, Florida. He had a dealership, he was an ex-Indy 500 racer. And that's how General Motors got the cars to them. John Glenn had a German car, didn't choose to get one. But then he gets the guys together, and you'll read that in his bio. He gets them together and chews them out, the other guys. He said, look guys, we worked too hard for this program. He said, y'all got to cut out this party because we worked too hard. Well, their boss, now they were all up at Langley, Virginia. I'll get his name in a minute. He told them they were getting ready to pick somebody to fly on Mercury, on Redstone. And he said, you put down, he told the 7 guys, put down who you think ought to be number 1. Put yourself number 2. So and now John Glenn, he was a fighter pilot in Korea, a Marine fighter pilot. Anyway, they chose, and John Glenn thought they'd choose him because he shot down 3 MiGs, World War II, most experienced. They didn't choose him because they didn't chewing him out. So they chose Alan Shepard, okay, to be number 1. Look at this. This is a letter. I want y'all to look at that. You make a copy of it. Look at it. Look at the date. That's from me to my mother in Daytona Beach, Florida. That's
February 13th, 1961.
Okay. She's at the airport in October. What you did, you got ahead of me.
Sorry.
See, no, that's all right. Leave it there. In October, she's at the airport coming to see her grandkids. In October. Who she spot there? Alan Shepard. She goes up to him and she starts digging in her pocketbook. I want your autograph. She finds this envelope. That's not the original. The original is at home.
Yeah.
That I had written her. So she gives it to him. He was startled, but he wrote. Now look where he wrote. Look on the back. See it? He wrote Alan B. Shepard. And that's dated. That's the date. Now look what he does. And he puts a 1 there. You see that 1? He did like that. My mother said, what's that 1? He's us first in space. She said, no, you weren't. The 2 chimpanzees were. He walked off. A true story, he was so upset. True story, and I tell that story. Now, normally I'll be down there showing you Alan Shepard, and I'll show the 2 Abel and Baker, the 2 monkeys. When I tell a story and I show the people that, and they all laugh.
Hold that up.
So that's just a copy.
Okay.
You got it?
Hold the other side of the copy up.
True story.
That's
so funny.
It is. And then he
Okay.
walked away.
And he got upset because, the road's named after him out there. He got to be an admiral, a rear admiral. Being a Navy guy, I know what that means. We went down May 5th that morning. One of the guys that got the plane, he'd retired from the Air Force, and it was the Air National Guard. They flew here. Now, in old days, the airport was downtown. The airport wrote his name because of the airport. And it was like a C-47. So we got on that and flew down. In fact, he flew us down there to that and landed at the Cape, and we watched the launch and everything. Came back, and what scared me, boy, it had crosswinds, and I thought that wing was going to hit the runway when it flipped. It didn't do it. He finally stopped her. But we were down there for that. When you think about it, and you look over here, that's that little old bitty thing. He's sitting in there by himself, thinking about that. Now we were kind of sweating it out with the engine. I'm thinking about the propulsion and everything, and we were watching. We saw it launch from this radar site, the test site and everything. And it was a wonderful experience and everything, knowing at least we got him up. Now, it didn't have enough thrust, to put him in orbit. He could just go up and down. And that's why he said he was first in space, till my mother corrected him. Now, she passed away 67, a long time ago after that. But she came up, I remember we met her, we had to go to Decatur. She came in and on the train, everything. So that's enough on Alan Shepard, I think. At that time, Alan Shepard, he flew May 5th, keep these dates straight, 1961, Now, the story I'm going to tell you now, I came across several years later from Missile Command, the Army. It was a write-up of questions to Wernher von Braun by LBJ, Kennedy's vice president, It is dated April 28, 1961. April 28, 1961. Question was, now think a little bit about Kennedy. He's our president. Think about, they've already put up a satellite, already put up Yuri Gagarin, and we have the Cuban Missile Crisis. Think about our poor president, egg on his face, and my concept, he didn't say that. He's concerned about what they're doing, the Russians. Pretty soon we got surveillance knowing they've got offensive rockets looking at the state of Florida, because my mother's still in Florida in those days, from Cuba and everything. They had to stand off to get those missiles out. So, questions, can they go to the moon? The Russians go to the moon. That LBJ asked von Braun came from Kennedy, 28th of April, 1961. It's probably 5 or 6 questions. And von Braun answered each one of them. Can they go to the moon? Can they put something on the moon? Can they go around the moon? What can we do that shows promise technologically? So von Braun answered each one of those, and I have that at home, by the way, what I'm telling you. And so von Braun is very concerned, about what they're doing. So he says in there, we could beat them to the moon. He answers back to LBJ, April 20th. Now, Alan Shepard flies the 5th, and your question a minute ago, May 25th, he commits us to go to the moon. 20 days later. See that? Now, just thinking about, now where am I going with the story? Leadership. Because I have people even ask me now, well, 12 guys worked on the moon, what does that mean? Number one is leadership. Kennedy committed us, got the whole country, including the Congress, to support us. But he got input from a guy named von Braun, leadership. So I tell them That's what we did. I said, your computers, all the stuff you have, iPhones, all that, where do you think all that technology came from? We didn't spend 10 cents on the moon. It was doing all this, getting ready, okay? So that's my story about that. Von Braun was concerned, and this is at the end of March, about the middle of March '62. John Glenn flew February 20th, 1962. So Von Braun called Dr. Mrazek, M-R-A-Z-E-K, he was my lab chief, and myself. He said, we're going to Houston and meet the guys from Langley. So he lets us read his speech on the plane. It was a chartered, and from the old airport where we left, chartered B-26 bomber. Noisiest plane ever been on in my life. And so he lets us read his speech, and he's going to read his speech to team up with them to go Earth. Well, first I should say, there's 3 ways to go to the moon. Make a rocket big enough, and Mrazek was already working on a Nova 50 feet in diameter, and that's another story I can tell you a little later about Nova to remind me. 50 feet in diameter, okay? And then Saturn, 33 feet in diameter, was working on that. And that's what Von Braun talked about that. Now his team wanted to go Earth orbital rendezvous. 3 ways you can go to the moon. You go to Earth orbit, rendezvous, send rockets back and forth, transfer propellant, go to the moon. The other way is lunar orbital rendezvous. And all that's described right back down there. I could show you that. And he wanted to team up with John Hobart, who was at Langley and came up with the concept, and his picture's down there, John Hobart. Team up and get a decision. He wanted to get a decision. We got to turn the whole world on. Got to turn the whole world on. Talking about all the contractors, got to finish up the design and let contract. 400,000 people got to get busy working on all this. So he knew that. So then he said, let's go down to Houston. Now they flew from Langley down there. There was no Johnson Space Center in those days. They had leased a motel that had been closed. I don't even know how we got there, and we was in a small conference room, very small room. Probably wasn't 12 or 15 of us there. I talked about the engines, the F1 engine and the J2, and Dr. Mrazek talked about the work we'd done on the first stage. And then Von Braun reads his speech that we'd already read on the plane going down. He wanted to team up with them to get a decision from Washington, plus science committees, and the president had a scientific advisor also they had to convince to get a decision to go LOR, Lunar Orbital Rendezvous. So that was very important in March. Now John Glenn is there with them, had just flown. They bring in box lunches, and here's McCool sitting by his hero for the box lunch. You know, we're eating and everything, and I'm just in awe of this guy, you know, still am. Wonderful person, down to earth, humble person, not a hot dog, served his country, he was a senator for many years and everything. So they make the decision, they're gonna go LOR. They tell headquarters, they get the whole world cranked up, and in a few months they make the decision to go LOR. Think about that, coming back to leadership. How the people, Kennedy and Von Braun, and of course, can't think of his name.
So they decided lunar orbiter was the way to go.
Yeah.
Out of the 3 ways, so the first way is the rocket.
Big enough to go direct.
Direct.
Now, Von Braun said, hey, we don't have time. He said, this decade. He said, we'd drop that. So we stopped all the work on the 50 feet, okay, 50 feet diameter. By the way, a sideline on that real quick. I meet a lot of people, some from New Orleans. We spent a lot of time, me, you, okay? I-10, you come over the Pearl River, there's an overpass been built because they were working already on the interstate system. Just a bridge to nowhere. You with me?
Yeah.
To let the thing go through on the barge on the Pearl River. We didn't need it, don't need it to this day for 33 feet. And people laugh about that down there. I don't know if y'all familiar with Huntsville downtown, where Gibson's Barbecue. There's a oversight there,
Okay.
an overcast. Same kind of thing with a bridge on I-10. You with me? To
then-
nowhere. And see, we built the first ones here, taken down on Tennessee River, Ohio River, Mississippi River, come back around up the Pearl River. You with me? In the Caribbean. Same thing with the second stage, because it was being built in California. Had to come by barge through the Panama Canal up into the Caribbean to the Pearl River, because we static tested the second stage at Mississippi Test Facility. Now you had to build it. Everything's big. Had big transporter, had a barge, big boat taking in, and we had a place on Redstone where we go down there, unload and load, and go. In fact, one time at Wheeler Lake, a barge bounced in, messed up the lock, and they had to build a road around the lock so we could transport. Somehow they built a road to go around and still transport, unload it, and load it on a barge down there. So, but everything's big now. That's got to remember that. Transportation is big. Now, second stage we had the barge yet. Third stage was built in Long Beach, California. Their static firing facility was in Sacramento. They could fly it in a Super Guppy, and we show that down here. It was 22 feet in diameter. It wasn't big as these. You couldn't fly any of this stuff, too big. We had all kinds of reviews and everything. Apollo 6, we had a problem, and I won't bore you unless y'all had time for that. It was the engine's problem, first day, second, third stage that we had to deal with, and thinking about Apollo 8 coming after that. How we dealt with that and what we had to do to fix it. Had a lot of people come here to meet, all the other leaders, contractors, vice presidents, you name them. No, we was under pressure. In fact, one time, I don't know if I ought to suggest this or not. We had problems with Space Division of North American Aviation, okay? The guy was the president, named Storms, Harrison Storms. And he had a lot of storm. They called him Stormy. I mean, he was a very egotistical guy. And we were meeting in the 10th floor of conference room at 4200. Von Braun sat up at the head of the table, and he jumped up. Herman Widener, who I worked very close with him, challenged him. And I thought they were going to come to fisticuffs. And Von Braun stopped everything, called it to order, and shut them up. But it was brutal. It was brutal meaning, a lot of pressure. So Storms got kind of teed off Herman Widener. I was very close with Widener. He worked in propulsion, one of the leaders. And he was challenging Storms. Finally, they had to get rid of him, and they brought in a 3-star Air Force general to head up Space Information System of North American Aviation, okay, to get things, because we lost Apollo 1. Same thing, workmanship problems. They built that, see. Well, I think first being in the military and being the one Marine, and Marines are part of the Navy, but they don't recognize, but they're still part of the Navy, and being involved with them and everything. My brother and I being in the Navy, I have a tender spot for the Navy people even today. I don't know. He just impressed me after the launch. And I didn't finish telling you the story in the meeting when Von Braun got through talking. They brought the box lunches in when John Glenn starts telling stories when he was a Marine pilot. His wingman was a guy named, I lost his name now, the last of the 400 hitter, Boston Red Sox, Ted Williams. You ever heard of Ted Williams?
Yeah.
He was his wingman. He starts telling us stories about when you're in your 40s, you ain't over the hill. This is John Glenn, and then he starts relating when he and Ted Williams were in Korea. okay, in the late 40s and everything. And Ted Williams was his wingman, and they tried to radio him. His plane was on fire. They couldn't communicate with him. They were wagging his wings, telling him to bail out, bail out. Well, he crash landed and jumped out. He didn't get hurt. He was lucky. But he tells us that, and he tells that story, the same thing in his biography, if you read that. So, but he's always, since he served his country and everything, and dedicated family man, still married to Annie. He wasn't fooling around with some of the other gals, how the other guys were doing. And I've seen a lot of that with some of the other, the astronauts. Some of them had got big egos and so forth. And some of them real good people. And started getting women, and they changed things. That changed things good. It was good. Sally Ride, so forth. But that John, I think, is just being a national hero to me, serving his country, being a senator, Ohio, doing a lot for his country, being in Korea, being a Marine pilot, everything. But to this day, of what he was a humble person. He wasn't no hot dog. Look at me, I'm an astronaut. He didn't go around flaunting that. So that was the last time I had seen him. And I did go down for the 50th anniversary, whenever that was in 2012, I believe it is. I think John Glenn was there in their space center. My wife and I were invited by the center director, and we went down for that, John Glenn. So, but he's still my hero. I met him after Challenger, and when I think about somebody, a private person, he wasn't a hot dog and all that, why he was picked to be the commander, I can see that. Excellent person. There's no question he was the qualified guy. And now when you read James Hansen's First Man, he talks about the intrigue, and there's James Hansen, who's an Auburn history professor. I met one of his students here telling this story one time. He was on sabbatical then, finishing up the book on Neil Armstrong, First Man, James Hansen. Now he's written one for John Young. He did his, and he did one also for a guy at Thykol, James Hansen. Excellent. I never met him. I thought I ought to get in touch with him and let him write one for me. I don't know, but he's an interesting person. But in there, Buzz wanted to be number one, step out on the moon. And it's mentioned in there, Neil said, no, I'm commander, and I should be first. And so he did. Buzz was kind of a hot dog, he liked it, and I know him personally. Neil is the leader, and there's no question about that. Now, Buzz got the doctor from MIT, and let me tell you, ain't no question about his history and experience and everything, no question about it. But he is kind of elated. He was on the program, Let's Dance, Dancing with the Stars, or whatever it was. Can you imagine that? You'd never see Neil or John Young or John Glenn get up there and dance, film and all that stuff. Hey, we're rambling now. Go ahead. Give me another question. Give me another question. Well, first, now let's think about it. We got to have the heat of combustion, and I got to be going 17,500 miles an hour to balance that, to stay in orbit. 17,500 miles an hour to balance that. So I'm doing heat of combustion to balance that, getting that velocity. Go to the moon, I got to have a lot more to get away from Earth's gravity, 25,000 miles an hour. Now, most of all of this is structure and propellants that we're carrying, okay, to do the job. So I can't go, Saturn 1 won't take us to the moon. Shuttle won't take us to the moon. Earth orbit, yeah, to do things in orbit. We put up space station, we put up satellites, okay? But to go to the moon, I gotta have something big. Now we started out with a Redstone engine was the first one. use different propellant. There's liquid alcohol, 75% alcohol, and liquid oxygen to modify the V2 to the Redstone. In addition now, we have a turbine, and we need to have power to turn pumps, a turbine. So we need a gas generator. Now on the Redstone we use 90% hydrogen peroxide. You pour it, you got a fire, okay? So you want that steam to turn a turbine, to turn the pumps. The pumps got to take the propellant out of the tank, force it in the combustion chamber. That's the alcohol and the liquid oxygen. So they're on the same shaft as a turbine. So the hot gas comes from the discharge that comes out of this steam pot, okay? I can show it to you on the engine sometime. We'll do that before we leave.
Okay.
Now all the other engines work very similar, okay? F1 has a gas generator. It takes kerosene, and I'll show you that when we're around on the other side. It's not on this side, I can't point to it. I got my pointer, my laser light. So what it is, you're taking kerosene as the fuel. Now we learned if you use jet fuel, high-grade kerosene, we get about 10 to 12% increase in performance, okay? First stage uses kerosene or jet fuel, like jet engines. And that's using that with liquid oxygen. Now, and we also want to mix them together. Now they have a gas generator that takes the same propellants, and then they got pumps. They're on the same shaft as a turbine. So the turbine is turned by the hot gas from the gas generator on the same shaft, liquid oxygen pump, kerosene pump. I could almost show you that right here with these pumps. Okay, that's on Pratt & Whitney pump. Now I use a different fuel, and I'll tell you about that in a minute. We need turbo pumps to take the propellant out of the tank, force them in the combustion chamber. We have to ignite it. We want the gas, the hot gas combustion, to give us the thrust. That's the thing that gives us the thrust. And then when we leave, I'm gonna let you look up inside this engine, and I'm gonna show you up inside what happens. You want to get molecules coming out to go supersonic from the hot gas. That's what gives us the thrust. Remember now, we don't push against anything. Newton's second law says for every force, there's an equal and opposite force. Kids know that, okay? They know about the laws of motion, Newton's laws. What we want is heat of combustion. So we carry the propellants, and that's what most of the mass is. The whole vehicle weighs over 6 million pounds, okay? So I need a lot of thrust. So the Redstone's, the first engine was like 78,000. And on the Mercury, and I need to digress for a minute, we changed the fuel from alcohol to hydrazine. And we upgraded the thrust from 75,000 pounds to 83,000 pounds. And we burned a little longer. That was for the satellite, and that's also for Alan Shepard's flight, and also for Grissom's flight, okay? So that takes care of the propellant was different. Then we went to kerosene. On the second stage and third stage, we want another fuel for high performance. High performance. We use liquid hydrogen as the fuel. Now, if you go back and study your chemistry, molecular weight is 2. It gives us real high performance. We get about 40% increase. Let me come back to the car now, okay? We always think about miles per gallon. You get a car, you know. My daughter got her new, I drive a Acura. She had to get an Acura, but she got a more modern one. Dad, I get 25 and 27 miles on a gallon. What do you get? I said 21, 20. You know, thinking about, it's the same principle, miles per gallon in your car. Performance what you want. And a rocket, same thing. Second stage of hydrogen, we want performance. The downside is, look at that rocket over there. You see the orange? See the orange?
Yes.
That's insulation. I got to provide insulation to keep it from boiling off. That's the downside, because it's cold, cold, cold. Second coldest liquid on the planet. Liquid helium is coldest. This is minus 420 degrees. Liquid oxygen is minus 300. Cryogenic. So you need insulation. And by the way, as a sideline, That's what happened when we lost Columbia. The insulation came off, impinged on the leaning edge of the wings of the orbiter, and we lost Columbia. The insulation coming off. Okay, so you need that. But hydrogen gives us high performance, but it has a lot of downsides, see, that you got to deal with.
Right.
Leaking, that's right, see. So we use second stage, third stage, hydrogen as the gas. Now the other thing we like to do is take advantage of the cryogenic temperatures. Now when we get finished here, we'll go look at the rocket underneath where you can see inside the liquid oxygen tank. Inside this liquid oxygen tank, by the way, that's the liquid oxygen tank right here that we're looking at, okay? We designed to put it forward, okay, thinking about a water tower. Water's up high, huh? You got pressure down below. So we designed to put the liquid oxygen tank forward, up top, okay? Get the elevation head for free, okay? It's tank with pressure, okay? So the liquid oxygen is forward, and we designed it that way. So we get additional pressure available for the pumps. These are pumps that you're looking at right here. These Pratt & Whitney pump, yeah, that's got a gear train between them. One runs faster than the other, and I'll show you that in a minute. So, but for pump performance, pumps like a lot of, just like you want your water when you turn your spigot on your house, you want the water to come out. Same thing in a rocket. The pumps want the pressure to be up. Now, in addition, we leave a volume above the liquid level, and we pressurize that from the ground with helium gas, okay? And as it expels, the propellant's being used up 3 tons a second per engine.
Wow.
3 tons a second per engine, 5 engines. And all that propellant's coming out real fast. First engine shuts down in the center engine shuts down 135 seconds, just commanded to shut down. The other 4 engines, when they run out of liquid oxygen, automatically shut down. There's sensors in the line that shut them down, okay? That's all part of the plan when it flies, okay? Now the 4 outboard engines are made to gimbal or steer the whole bird. And I can show you that back there with actuators, hydraulic actuators. Our guy's one of the docents, go back and look him up, Charlie Johnson. He died.
Okay.
Ask somebody about Charlie Johnson and give you a copy of his card. He designed the actuators that move the engines. Y'all with me on this thing? Well, you can't see the gimbal bar. You see there's a V coming down here? That's just a tie for the actuator where it's tied to the vehicle. But on the front of it, I could show you there's a big spherical ball that's mounted to the thrust structure, okay? Now the instrument unit, which is up forward, has the guidance system. It tells it when the bird takes off, it does like that to get away from the tower. So you don't bathe the whole tower, 5,000 degrees temperature. Still have to replace a lot of hardware. So it does it, and it tells it which way to go from the guidance system, and it's moving. Charlie came up with the idea, instead of using hydraulic oil, let's use the kerosene. It's a hydraulic fluid. That was his idea, Charlie Johnson. He passed away. He worked for one of my guys in hydraulic, what we call the thrust vector control system. That's what he came up with. That way we didn't need to use hydraulic oil like you have in your car. It's no different than your power steering uses a different fluid than your hydraulic brakes. You with me on that?
Yeah.
So then the other thing is on the engine, the valves on the engine can use the kerosene. They're pneumatic valves, okay? And they use the hydraulic fluid to open and close. With me on that? Mm-hmm. Okay. But that idea they're using the fuel. The second stage and third stage, and you can barely see the engine. There's no actuator that we can see that move those engines. Same principle again. They use hydraulic fluid like your car. It's a military specification. Military 5606 hydraulic fluid that uses that. But the point I want to make was the hydraulic system that we have on the F1 engine, including the valves on the engine, can use the kerosene. That's just a fluid. Okay, kerosene. The other is an oil. In other words, so Charlie came up with that idea, and that's what we have. And he was a docent. He died probably a year ago or something. He came here with it.
But he revolutionized
Yeah,
basically the way that was done.
Well, that way, see, the thing, what you have, that's something else you got to deal with. If you got to have hydraulic oil, like particularly in, say, missiles, you have to have that. You have to have liquid oxygen. You had to have peroxide. I told you about 90%, and that's nasty stuff. You don't spill that. That's bad.
Yeah.
Bad. Kill you. And see, I need the velocity of 25,000 miles an hour to get away from Earth's gravity. See, I got to get away from that to get there. Then I got to deal with the moon gravity when we get near there. Okay, it's all that, and I don't get involved in all the orbital mechanics. I can't even spell the word. So, but it's all you have to design and account for these things. See, so you can't. That's just not enough rocketry. Now the idea, what you bring up is good. Turn around and look at that Saturn 1. See that Saturn 1 right there? See it?
Yeah.
That model? That's a Saturn 1B. Now see the fins? Now when we designed that, that's a good question that you asked. Von Braun said, why don't we cluster engines in our tanks? Now look at the tank. You can see the tank where it says United States? There's 9 tanks there. 9 tanks. 4 of them are for the alcohol, okay? No, that's kerosene. That's kerosene. I'm thinking about Saturn 1. 4 of them, but what it was, the Redstone Missile has a diameter of 70 inches, okay? When we worked on the intermediate range ballistic missile Jupiter, it's 105 inches bigger. Now it had the H1 engine or S3D. In fact, the engine looks just like that engine right there. That's an H1 engine there, okay? Use kerosene and liquid oxygen. And that one develops pretty close to 200,000 pound thrust. When we started out with the Jupiter, the 150,000 pound. Kept upgrading everything. When we clustered the tanks, now we had to cluster 8 engines in that first stage. Now think about a plumber's nightmare. Seriously, you got to take propellants. Now think about this. For the liquid oxygen, I got 5 tanks. Now the engine likes to run a little more liquid oxygen than kerosene, so it likes more. It runs on a mixed ratio of 2.25, 2.25. Almost 2.25 pounds of liquid oxygen, 1 pound of kerosene. Okay, so I got to take the liquid oxygen out of 5 tanks and put into 8 tanks.
So there's a lot of components.
5 engines. I got 8 engines, but I got to have for 5. Okay, 5 tanks delivering into 8 engines. Now that's easy when I got just 1 inlet per engine. That's the only one. Let's see if we can see it here.
Yeah, we can walk over there at the end and you can kind of show us.
I can't see it here. Well, that's where the gimbal would be, where the brown is. See the brown?
Yeah.
There's a ball right inside. That's where the gimbal bearing is, where it's mounted on the thrust structure to do this and move. It's got an actuator that moves it. But what I'm saying, you got 9 tanks, and on the fuel side, there's 2 inlets per fuel engine. So I got 16 inlets. I got a manifold system that's bringing all this stuff out of the tanks into different engines. We worked on that. The valving system, crosstalk and all that. Now the big thing, everything was big. The thing is, let me show you. What I want to show you, can you see those tubes? Those are tubes. Okay, there's probably 100, almost 100 of them. They come down and the kerosene flows through those, okay, and goes back up. Okay, that's how we keep the nozzle cool. Same thing, we can look on that one. Look, see right here? Look at this one right here. This one right here. These are hydrogen tubes, okay? Keeps the nozzle cool.
Okay.
Now think about how they put that together, and they're tapered. In Rocketdyne, you got a big engine. That engine, see how high that ceiling is? We got a an oven like your kitchen oven, because they'll lay solder down in between, taking in the ovens that big, as high as that is, at Rocket Center, Canoga Park, Los Angeles, okay? Big facility, big, everything's big. Look how big the tanks are. How you move those things. Now you could, once you build this engine, you can transport it on a truck. We sent dummies over, accelerometers, measure loads and all that. And that's how you could truck it to Huntsville, the engine from California. On the big bird, we had to go on a ship, barges, transport that, okay? When we started on the F-1 1958,
Okay.
so they started on it. DARPA had funded that. The Air Force didn't need an engine that big. So we started on that in 1958. Okay, and we didn't fly. I forgot when the first Saturn was flying was Saturn 1, Saturn 5. Saturn 1 did fly on this small engine, but we didn't fly the F-1 till many years later. So what I'm saying is getting ready, designing the tank and everything. We had to do static firing on each vehicle before we'd fly. Everything was static test the engine by itself. Had 2 test stands out at Marshall. One had a single engine test stand, put the engine in a test like this by itself. Okay, instruments, hundreds of instrumentation, and we look at all our records, see what needs to be fixed and so forth, how it performed, pump performance, and so forth. Next thing did, had to cluster the 5 engines which you have there, put them in the stand. Same thing again, all instrumentation. So we're looking at all that data, records and everything. I mean, miles, oscilloscopes and everything. They'd lay them down on the floor. We'd walk down through the halls and look at records there. And pretty soon they got smarter where the gals could read them for us, calibrations and all that stuff. So when I say years, it was years preparing stuff. Now, it was not NASA building all the hardware. It was the people in this country, mom and pop shops, small companies that make pyrotechnics. You know, there's over 40 rockets on our hardware rocket. When you think about it, we've got thrusters and all kinds of little things that they have. Of course, you got them in the payload, rockets everywhere. Mm-hmm. So it takes a long time, but you got a lot of talents, a lot of people. Yeah, and then you got, how do you make them? See, like I was telling you about, like a furnace oven where you have the solder, you have to melt all that. Then after later on you do pressure tests, pump water through the thing, see if there's any leaks, then have to go back and repair them, all the things. No, what it is, you see, just the idea when you see a component test. See, von Braun always preached to us, test, 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 test. We take a valve or take a pump by itself and test by itself, put it on a test stand, okay, then put it in a subsystem, okay, with the lines and feed duct. And ultimately what you have is a cluster, okay? Now that's just the static fire. You don't really know till you fly. But there's other things you worry about, where we did a lot of vibration testing, like we did modal testing and everything in a big test stand there to understand what it's doing. You don't know that till you fly. But we have a lot of instrumentation. And that's how we knew we had problems on Apollo 6, because we had a lot of instrumentation. And what we saw, like thermocouples in the aft skirt, as it flew, we got the information back, telemetry, okay? Coal, like liquid hydrogen. So we knew we had hydrogen leaks and find out the problems on top of the engine. Can you see there's another engine right there? That's the engine up there on the S2. There's a leak up on top. The line broke. That's what happened. We had the instrumentation. We started working on the thing, trying to find out what happened. And what really happened was, y'all familiar with water hammer? You know what water hammer? Y'all familiar with, look on your computer, Tacoma Narrows Bridge. Tacoma, T-A-C-O-M-A, bridge failure. And what it is, that's in Washington, state of Washington. It's a bridge, it's a suspension bridge. And the wind was blowing like this at it, and to set up a resonant condition, okay? It resonated, it was in harmony, and the bridge collapsed. And
Heard about
okay,
this.
all right, now look it up and it tells you it's a similar principle that we have to deal with in a rocket, okay? If you have flow through a line and you got bellows, okay, the flow comes off of that, it can set up a vibration, and that's what happened. We tested on the line, when first tested on the ground, okay, we didn't know there's a hydrogen line going through there. Didn't have a problem. Went in flight, come to find out, no ice. It was sitting on the ground, the line inside of liquid hydrogen, it freezes liquid air. So the line didn't move. How'd we prove that? Put it in a vacuum chamber. Sure enough, it failed. Wasn't no water, wasn't no ice to freeze. The line failed. So we got rid of the bellows. That's how we learned that doing testing in a compound facility. Nobody's around. We got a lot of measurements and all that. But it's a resonant condition where it gets in harmony. It's a little bit like when you turn your water on at home, you can hear water hammering. That's a similar thing. Flow, resonance. But that's a pump right there if you want to look at it. And I'm going to let you get there and push that button.
You want me to push
Go ahead,
right
push it.
now?
Yeah.
Okay.
Watch it working. Now look at it. Look at it. Look at it good. Look, see where my thing, that's the inducer up there, and that's the impeller underneath. That's the turbine right there. Is driving it. Okay? That's a gear train. That's a liquid hydrogen. That's liquid oxygen. Look how slow it's going.
So they have to move at different rates to have it all go together.
That's difference in density. Okay? They still fly that engine. That's the
Still used?
that's the first liquid hydrogen engine anybody ever had. Pratt & Whitney developed that. West Palm Beach. If you look at, well, it was on Centaur. Centaur used those. Only developed 15,000 pounds of thrust. Saturn I had 6 of those engines. Manifold system problem too. The noise was something else.
Oh yeah.
It's the second loudest noise on the planet. People don't realize that. And I tell that story. It's been measured like several on the Richter scale. Bob Sadler, I called him, getting off on that story, and asked him, did they have any kind of recordings I had heard a rumor that Penn State turned their seismograph on. He said, no, but he got a call from the police department when they tested that in Birmingham that they saw a lot of rocks and stones on the roads and everything, so the sound traversed through the ground in Birmingham. But he didn't know anything about a seismograph. Now his health is not very good. He's still alive. You see his picture. He's a test conductor on that one when he did that. Big milestone. But that was later. That was in 65, I guess it was. Well, it was sadness, really, but we started working on Shuttle and wanted to get something reused. And that was the next thing we started working on. It's all about propulsion, same thing. And there I was back in propulsion. In fact, I headed up a lab, propulsion laboratory. I don't know, I had several hundred people, a lot of contracts, civil service. But it's fun stuff, new. Houston worked with us, the Air Force worked with us. Now, we haven't talked about the F1 combustion instability, okay, Saturn, F1. Okay, that's a big thing. I was heavily involved in that. Now I'm back on Saturn V, but it's F1. we were just blowing up, and you can see it in the movie. It self-destructs. It sets up high frequency vibration, millisecond, destroys itself. I set up one of my guys, Jerry Thompson, who's deceased, Thomson, his name's mentioned there, ad hoc group with our contractor, Rocketdyne. They set up Paul Kassenholz. We had Princeton University under Dr. Luigi Crocco, C-R-O, something like Crocco. Okay, they were giving us the academic side of it, try to understand. Now, appreciating these days, this in the early 60s, we're still using slide rule, didn't have no high-speed computers. There's all kinds of speculation. What sets this thing off so it triggers itself and destroys itself? Now think of it, you're blowing that whole engine up in a test stand. Nobody gets hurt, they're in a blockhouse, but you're really tearing up a lot of hardware and test stand, setting us back. Well, that went on for a long time, and the guys trial and error, came up with a configuration, and I could show you if we look up inside there, we can almost see it in the picture right there. Came up with a configuration that had baffles inside where the injector is. And so they came up with this design, but it was trial and error. And we blowing up engine, try this configuration, build it, go test it, blows up. A lot of instrumentation. Very expensive. We spent over $40 million, 1960. You think that's billions today. Okay? So Crocco goes on sabbatical. He's in Rome, Italy. I told Jerry, I said, hey guys, get the drawing of the latest configuration. It's got the baffles in it. You guys get on the plane, go to Rome, show it to him. Should we build that? They go over there with the drawing, come back, he said, yeah, let's build it and test it. So they come back, they said, I had to rebuild the thing, start over, okay? And that takes months, when you say it takes time to get another one, build the engine, put it all together, instrument it, and then go out and test it. And that's really what you see in the test now. So to this day, it works. The baffle works. I can't explain it to you mathematically why, but we spent a lot of time. It brought us to our knees. Sonny Maria, he was a manager. Y'all have had him lately talking about, and he likes to talk Lunar rover, but he was the manager on this engine back then. Okay. I was in engineering. See, we were doing all the engineering for him.
Okay.
So if you talk to Sonny about combustion instability, okay, combustion instability, he can help you with that. Now, there's another guy I had in the lab, his name is Bob Richmond. Now, we had a symposia, with the 50th anniversary.
Yes.
Did any of y'all happen to go to Ron Bledsoe? Bledsoe had a...
I don't think I was at that one. I've been to a number. Was it the past?
Well, now Bob Richmond was there, and he's probably got some pictures and stuff like that. But Bledsoe, now he's a docent. Okay. If you could get copies of those papers that we had in his panel. Bledsoe was the chairman, okay, and I was his assistant. We had all these other guys, but Bob Richmond talked about, and Sonny's on his committee, okay? So Bledsoe can help you with that. The combustion instability problem we had, and then getting ready for it. Because Maria was the manager. He was the one putting up the 40 million. But I really needed to tell you that was a milestone. Now you can see it in the movie at the start. Watch it from the start. Keep watching the engine. You'll see it blow up. And I tell the people. And in fact, I got my laser light looking, so they'll watch. But we solved that problem and don't understand it to this day. And you know what we call that injector? The kitchen sink injector. Tried all the recipes, trial and error. True story. Somebody said, what do you mean by kitchen sink injector? I want to see that. Bring them down and let them look up inside and you see the injector. Have a laser light, they can look up in there.
Sometimes that's the best engineering is when you just put it all together and it works.
That's right, see? Don't understand the physics and the mechanism. We know it just done self-ignite this problem and destroy itself. I mean, in milliseconds. You'll see it in the movie. We, in our engineering group, we had thermal people. Remember now, we really had problems going uphill. That was our contractor. The meteoroid shield tore off one of the solar systems. So we had to rescue the thing. And that's when I was going to learn how to be a rescue guy. I started learning how to be scuba diver in our neutral buoyancy tank. We had the only tank, and the astronauts would come up here to learn what kind of tools they're going to need once they go up in orbit on Saturn 1B. So we were heavily involved in that, on the repair business and what they're going to do. Our engineering people, thermal guys, were telling them which way to look so we're not barbecuing on orbit. Worrying about temperature because it's got inside insulation. Eventually they're going to have to live in there. So we were able to, well, in fact, when it came down, 1979, trying to think, Ozzie Harrison went to Australia and brought the liquid oxygen tank was sitting there. He went over and got one of my design guys in our lab. So yeah, we were involved, but concurrent with that, I was in Houston in 1973 working, trying to get a contract for the orbiter, and also the tank, the external tank that we had that we make in McCool for the shuttle. So we were heavily involved in that. And then I had a solids group that worked on solid rocket motors with Thicol. I had all the propulsion stuff. And so I was heavily involved in that. We stayed busy, traveling a lot, you name it, and so forth. Had a lot of difficulty on the Space Shuttle main engine. We had that one. And that's an interesting program. I had one group that took care of that the whole propulsion. And my lab was called Propulsion, Structures and Propulsion Lab when I had that. I had an analytical group, could do dynamics, could do stress analysis, could do design tanks and all that, do thermal analysis, fluid analysis, and then also combustion dynamics. But we started working Shuttle, see? That was going to be reusable, not dumping everything in the ocean, like the F1. By the way, they've recovered some F1 engines.
Oh, they found them
Yeah,
actually?
they found some. There was supposed to be a seminar coming up on that with the 50th anniversary. Check on that.
I will.
Somebody's going to talk that that's been involved. I hadn't seen. Now, a lot is not going to look good because I can tell you on Challenger, okay, we found the engines on Challenger and it was eat up with marine growth. They were in the shallow water. And that's where the marine growth seemed to be. So I don't know, there's a lot of aluminum on there. So I don't know what the engine's going to look like, but there's a discussion on that. John Young was one of my heroes, who was commander on Apollo. He was commander on Apollo 16. He was commander on the first shuttle, STS-1. He flew on Gemini, and you know the story maybe, with Gus Grissom took a corned beef sandwich on orbit, got in trouble about that. I don't know if they ate the sandwich on orbit or when it landed in the water. Anyway, John Young, he was a character. Now, the orbiter, or the command module, is Apollo 16. First time I saw that, and what had happened, I hear him talking, and Charlie Duke and those guys, and I was at the Cape, and I said, I'm going to call John. I'd gone to Orlando, got a rental car, driving to the Cape. I had his number. I called him in Houston. He lived in Houston, still working. I said, John, I said, we had our off-site with all the shuttle guys, and you were there in San Diego. And I said, my wife went with me on that. We took a harbor cruise, had a destroyer named John Young, named after you. I said, now I get out down here, and here's a command module. It's named after you. I said, I am so impressed. And I get to Orlando. Orlando is a boulevard named after him. Somebody named that, and I called. I said, I'm impressed. He said, these little old ladies called me from Orlando about the red lights, the timing on them. He made that comment. He said, I wish they calling me. And he lives in Houston. He ain't got nothing to do with red light. But he made that comment. Now, John died about a year ago, had Alzheimer's.
Okay.
I think. I don't know. Another friend. I was heavily involved, Challenger, and long by the time Columbia came on, I had 4 bypasses. And I really wasn't involved in the launch on Columbia. I was on Challenger. One of my guys, he's passed away, disease, Leon Ray, kept telling leadership he would go down, and when they recover the 2 solid rocket motors, they'd bring them in. FICAL would bring those in. And take them, disassemble them, and look at them. They could do that. And they look just like these, or what you're looking at. Those are 5 segments, we had 4 segments. And sure enough, you were getting blow-by, the O-ring about big as my finger, made out of rubber. And hot gas coming by. Now what I think happened at the start, I was down there for the launch, and I won't go into that. There was a problem we had on a payload, and I was the chairman of to look at what happened. And what had happened, they landed the orbiter on the west coast, and then it flew back to Kennedy. So I went to Kennedy, and they had the orbiter unloaded that, and we were dealing with that. I wasn't involved in the launch, but I watched the launch, and I saw it. I was there that day. We'd gone down the day before, and so I had nothing to do with that. But the bottom line is, they would bring in the segments and they disassemble them, and they look at the O-rings and everything. Sure enough, now what happened, if you watch a launch on a shuttle, what happens, the 3 engines on the orbiter, look at the model out there, the real model, and the 3 engines are like that. And when they light off, they're sitting on the pad, okay, T-minus 8 seconds, okay, the whole bird rotates. Why? Because those 3 engines, the Space Shuttle main engine, light off, okay? And the bird rotates almost 18 to 20 inches. It does this, okay? When it comes back, then they ignite and separate from the pad, okay? And that's when all those rockets take off. And that's when the thing they saw later on, Jim Earl, one of my guys, started looking at film, and sure enough, they saw they had film on the pad. They could see hot gas coming from the solid rocket motor impinging on the hydrogen tank. Okay? 5,000 degrees in the hydrogen tank. Well, it's 73 seconds later. That was it. O-ring leak, we lost Challenger. They set up a committee, and then they wanted, Bob Crippen was down there for NASA. He flew first mission with John Young on Shuttle. Lives in Orlando. He wanted somebody to come down, work with the Navy on what they're looking for. Now they had the medical people, had nothing to do with that. And so I went back to the Cape on February 9th. That happened January 28th. And then I went down February 9th, worked with the Navy on recovery. And I had a team of guys that helped me, including Air Force, including Marshall people, Kennedy people with that. And they had Johnson & Johnson Pharmaceutical Company oceanography in Fort Pierce, Florida. They had 2 submersibles, looked like a helicopter, could go down in the water. Very expensive oceanography work. They do research. So the Navy had them under contract to come up. And I could put one of my guys on it. They carried a crew of 2, and one of my guys, John Key, was on there with me. And it could go looking, and that's what they did. They had the recovery ships and plus other recovery ships going back and forth with side scan sonar looking for hardware. And that's what we were doing, look for the parts. I finished that up. They did find the space shuttle main engine, they recovered them, all banged up. Had to set them up in a hangar. They set up some of the parts for the external tank that we found, a lot of insulation. We found the range safety system was still live. We had to put over on a safe area on Patrick Air Force Base where we could think it'd blow up. Just put it over in a safe area. I forget when it was now, in late February, I get a call on Sunday morning. They found the part that failed. It was about 35, 40 miles out. And they had a salvage ship out there the Navy had on the contract with a 100-ton crane. Well, they could hook up with robotics and could pick that up, which they did. So Leon and I were down doing the other thing, working with the Navy. We go out on a Coast Guard cutter, go out, bad day, rough. He got sick and I didn't get sick. We went out 40 miles. Rough, boy, rough. Well, it was about 80 foot long, good sized ship. We get in this little pontoon boat to go over to the salvage ship. Now that gets spooky. They suited us up, life preservers and rain suit. Said, okay, we got to take you over to this other ship. Man, if you be down in the valley, you couldn't see nothing. Be up on the mountain, you can see all the rides. Scary. We get over there, and here's this big salvage ship, and there was a line hanging down with a ladder called a Jacob's ladder. It said, climb that ladder. Now, I thought it was high up. It scared me to death. I'm first going up, and everybody doing this, and that ladder is moving. And I got at the top, and I'm about to wet my britches. First thing I'll say, where is the head? That's Navy for bathroom. They took me straight to the bathroom. And so, anyway, we went down and looked after that, and there's the hardware they recovered. The first piece. Okay, and you can see the flame, or the hot flame, like a acetylene torch cutting. And so, we took pictures, we had a camera, and we did take plastic bag. We took some cardboard and made a template of what that looked like. And made notes, made measurements. Then we had to come back down the ladder, get on that boat and go back. Whew, man, was I sweating that out. When we get back to Port Canaveral, it's like midnight. We all wet, and he's sick as a dog. Everything. I said, now, they're gonna want us to have this film. We gotta get out, and this is the next morning, Monday morning. So we go out there, and first thing they want to develop the film, and they do. And they told the barge, the big barge that had the ship, bring it in, come on in. So they came to Port Canaveral. Now we didn't have anything to do with the crew. They had the medical team down there, and they worked with the Navy also. But we had nothing to do with that, just looking for the hardware. So they did bring the hardware up, and was able to set it up over Patrick Air Force Base in an area. Now what you worry about when you have ammonium perchlorate and it gets salt water, it can be dangerous. It can ignite. So they set it up in a hangar over Patrick Air Force Base. In the meantime, here's all the Rogers Commission people wanting us to take them over there to look. So the next day, we're over there looking at all this stuff and showing them and telling them and everything. And that's when I met Neil Armstrong. Rogers, Secretary of State, he was the chairman, and Neil was his deputy chairman, okay? That's why he was there. They had other dignitaries and people to help them on the commission, so forth. So bottom line is the O-ring failed. We lost the crew. It opened our eyes. We shouldn't have launched. Leadership said, let's fly, and made a mistake. And they made the decision to go that next morning. And I was across, I had binoculars because we had gone down there and I was watching it. And I saw it and we knew. And NASA had 2 planes. I went down on a King Air and the other was Queen Air. And they went down on the Gulf Stream. Well, I stayed till midnight that day down at KSC and we all trying to figure out what happened. Nobody knew. We came back the night, probably the 29th of the next day when we get home. Came back with them and we set up our team, contingency team. Now I had a contingency team for me. They had people that would look at the tank, would look at the motor, look at the engine, all these all set up, and they had, my job, I was chairman of the payload. Now the payload on Challenger was 2 inertial upper stages. The Air Force thought they were going to put up a satellite. They had solid rocket motors, so we had to see, because they inadvertently ignited and caused the failure. So Boeing has people come, Air Force have come, we're all here meeting at Redstone. That's my job.
Okay.
So February 9th, I go back, and we had settled our problem. It wasn't a payload.
It wasn't a payload.
So that was my job so far as looking at that. But then we had to work with the Navy so far as recovery.
Okay.
And that got kind of bad, seeing the parts and all that, and hearing about the crew, the lost crew, everything. And I still live with that, and I live with Columbia, problem with insulation there. See, what happens, things will happen, and you should take action, and you get too busy doing things and pushing. And I find myself sometimes trying to do more than one thing at a time.
Right.
And when I do, I screw up, and I really mess up, okay? I came here in '54, worked all the programs, Saturn, Skylab, and then the payloads that we had, worked on Shuttle. And I was manager of Shuttle till 2004. And I retired 2004. Started coming here, and I used to come here when some of the previous directors, and I would do a program that NASA had. We bring school teachers from all over the world, and I would bring the Germans, the old timers. We'd have a call von Braun Forum, and I would organize that, and I'd be the moderator. And a couple of times we met in the education facility, another time in where the kids, and there's an auditorium over there. We met there. And then we'd go out in the hall and have German restaurant food for
Food
them.
out there for him?
Well, pretty soon they're dying off on me, and we quit doing it, didn't have it anymore. So 2004 I started coming back here, and I enjoy coming here. Now, people say I'm probably one of the oldest ones to come here, and I don't know, but December 10th, I'll be 96. December 10th, birthday coming up. But people say, well, what is it with you? I said, well, I go to the gym 4 and 5 times a week. I said, I used to be a runner, and I try to take care of myself. Probably overdo it. But I've been coming here for my mind, like talking. What I'm talking to you about helps my mind, my computer. So you're doing a blessing for me. You guys are helping me, and people want to know it's giving me longevity. It's the rest of it, not just physical, but the computer. Talking about John Glenn, talking about Alan Shepard, John Young. Well, I honestly think the future is still going into space. Now, I was privileged to be invited with the Vice President when he was here, he committed us to doing it in 5 years. I said, I'm not sure that can be done like we did on Apollo. Now that's different. You got to have a commitment by the country and its leadership. Now, will leadership do that? I think space still excites people, and I see that here. I'm around the young people here. Space excites me. I've had one of my great-granddaughters come to space camp, and we're trying some of the others to come here. Some of them are in engineering. In fact, my grandson works for NASA. My son worked for a contractor, worked with Boeing, and he's working for Boeing now. And so we're all associated with space. Space still excites people. It's still the future when you think of what we can do. I like the idea of inviting contractors and society and being involved in the thing. I think there are some things that we can do. They're showing us we can do it. SpaceX, I've talked to his propulsion guy, SpaceX, Elon Musk, space guy, took him on a tour with his wife and kid on them, and I'm impressed with them, what they're doing. Clustering engines like we did, which is what the Russians did. We did on Saturn 1, Saturn 1B. That's important. You ought to be looking, what else can we do? What can industry do to help us? So the future's still there. The excitement's still there. Let's keep going. Let's keep going. Let's bring up some new things. Having said that, I don't have a computer. I don't have an iPhone. I got the old time cell phone, so I can call Mom when I leave here, put the food on. Black beans and rice for lunch. Thank y'all for what you're doing. Space camp is important. Space and Rocket Center, I tell people, there's not another one on the planet